Hello, and welcome to the Perils of SaaS Collaboration. Who are the data? Where are the data? And who has access? So a bit of an agenda. We're going to go through an introduction, some background on this topic. Then we're going to talk about collaboration issues, insider threats, risk management, incident management, and then at the very end, we'll have time for a Q&A. So I'm Max Feldman. I'm a security engineering manager here at AppOmni. In the past, I've worked in product security roles at Salesforce and then Slack, and have since moved into AppOmni to work on doing more SaaS security for different clouds. So let's talk a little bit about collaboration and how it's evolved. So this is not an exhaustive list of all the ways humans collaborate, but just a quick intro. So before the cloud, you had people who could communicate in person. You had letters, you had the telegram, then the telephone. So communication has always been around collaboration. Humans are a social species. And there are a lot of ways that folks collaborated. So you had salons, eventually electricity came in and you could have real-time communication at a distance, and you had phone calls and conference calls, faxes, etc. Then we're getting into mainframe computers, shared resources on single large computers, then local networks, on-premise networks, version control started to exist. More and more personal computers started to exist. Email, the internet. So we started to have digital instant communication and collaboration across various media. Maybe you download a file on a USB stick and bring it to another computer to work with someone else. Maybe you email them a document. Maybe you have the mainframe and a handful of people accessing the same document or using like early versions of version control. The internet really opened up a lot of different ways to collaborate. Then we get to the era of the cloud. So the internet grows, SaaS begins, docs, code, data, everything can be accessed in a browser. More and more things pop up. You have social networks, MySpace, Facebook. You have all sorts of messaging and communication beyond just email, and lots of rich apps and web apps that are starting to host data and let you edit it in the cloud without needing to download a file, without needing to email it, without needing to put it on a USB drive and bring it over to some other place and work on it together. So we now are in an era of the cloud where we've got Salesforce, we've got Google and their products, Microsoft and their products, Slack, Zoom, GitHub, Workday, ServiceNow, just all sorts of applications. And this is not even scratching the surface of all the cloud means of communication and collaboration. There's tons of video chat, there's tons of document editing, work, productivity, CRMs, all sorts of things that companies, businesses, organizations, and individuals are using to work together in the online age. It's been growing in popularity for years, even in offices or spaces with VPNs or local networks. You're starting to see more and more cloud products, and like sometimes there are on-premise things, but a lot of places are shifting away from on-premise and moving more towards these cloud applications where everything is hosted by someone else. So early on, in the early stages of SaaS applications were relatively simple. They were accessed primarily through an enterprise network. This is when Salesforce was truly a sales-only solution and was only used by a company's sales team. So then they grew, and they have grown, and they continue to grow into complex platforms that now have an unlimited number of access points. It's no longer just a small percentage of internal employees accessing SaaS. It's everyone. It's everyone across multiple organizations: sales, customer service, HR, engineering, marketing, etc. You have customers, partners, contractors, third-party individuals. Maybe you have IoT stuff plugged in. Maybe your SaaS applications are linking internal users and external users. So you have data, maybe it's customer support cases that are being worked on by multiple parties, including contractors. So you have all sorts of stuff going on in these complex platforms living in the cloud. There's also been a bit of an impact from COVID. Well, not a bit, like a significant impact of COVID and work from home on SaaS adoption. So App Omni conducted an independent survey of over 200 IT professionals who, as part of their daily tasks, manage SaaS applications. This was conducted in September of 2020, but we saw that 10.4% of organizations had no increase in SaaS adoption, 21.4% were already heavy SaaS adopters, and 68.2% saw increased SaaS adoption. So um, anecdotally, I think we've all kind of seen this in the working world, more and more companies embracing SaaS and embracing solutions that are easy for work from home, that let everyone work from wherever so that they can continue to work. So now let's dive in a little bit onto threat models. So we talked about the evolution of SaaS and the evolution of collaboration, but we also have to think about the evolution of threats to the data that's stored there. So let's look at pre-cloud. So some of the pre-cloud means of communication, like in person, you're just talking, you're in a salon, you're in a town hall, a public forum, etc. You're writing letters back and forth, you're sending telegrams, you're making phone calls. So what were the threats then? Theft. Your letter could just be stolen. Forgery. Someone else could send your letter. Pirates. Like you're shipping letters on a ship and it gets captured by pirates or it sinks. There's weather. Like weather can take down phone lines. So that's like the availability side of it. But if people are taking your letters, if people are taking your forms of communication, then that's a violation of the confidentiality of it. Forgery, if your letter is just wax sealed or not, and it's just a signature, like maybe that's pretty easy to violate the integrity of the data. Phone lines can be tapped. In an in-person conversation, someone can just overhear what's being said. In certain time, I don't know, in times of unrest or upheaval, perhaps there are people listening in for conversations that may be threatening to whatever powers exist at the time. There's a wrong number. Maybe you just dial the wrong number and start saying stuff into the telephone and then don't realize who you're talking to. Maybe the post office delivers your letter to the wrong place. Like there's a lot of threats here, and some accidental, some intentional, kind of a different threat model than we're seeing when we start getting into digital stuff. So then we're looking at mainframes, local networks, on-premise, version control, et cetera, et cetera. We talked about how that was working. What are the threats there? Hacks. As we get networked computers, we start to see viruses. We're getting into an era of modern computer security threats. So the things we think about when we're doing application security or product security or just general threat modeling, these are the threats that start to come to mind. Organized crime, cybercrime, advanced persistent threats. All of these come into play even before networked computers, but once you're starting to get networked computers and once you're on the internet, the threat models start to get a lot different. Then we see a further evolution of this as we move into the cloud. So we have all of the regular threats of doing anything with computers. So what we just talked about. It's important to keep in mind here that all of these cloud providers, all of these companies have great security teams. They spend a lot of money on hiring really good people to make sure their apps are secure. They have some of the largest and most talented security teams in industry and in the world. So they're taking care of some of that security side of things, but these apps are very powerful and they're very complicated. So you have to be mindful of things like shadow IT. Like, are people just signing up for things because they're easy to sign? They're better products, they're convenient. So you have your employees just getting on Slack, getting on new messaging platforms, starting to use different version control because it helps them be more productive. These are powerful applications. So misconfiguration is a huge issue. Misunderstanding of the platforms, like what are the defaults, who can access what data, what is expected to be secured by the company, by the SaaS provider, and what is supposed to be secured by you, the person administering it. There may be multiple admins on these apps or on these platforms across the company, across organizations, even within the same organization. And third-party apps connected to the SaaS apps also really change the threat modeling here and the data access concerns. So pre-cloud, who has access to your data? It's the users on the computer and whatever programs are running. So if you've got endpoint management and you say like, okay, no one can do this, or we have a firewall, no outbound connections. Like, sure, okay. Now we're in an era where a bunch of data is in the cloud and a bunch of apps are connected to that. So it's another layer. It's more nuance and subtlety to this, in addition to all the regular old computer threats. So the complex nature of the SaaS platforms has introduced new security risks. So let's look at third-party apps, for example. So these applications are connected to your SaaS environment via OAuth or other verifications, other install flows, really depends. Third-party app examples include like lead tracking software, marketing survey software, AI tools. You got like productivity things, developer productivity things that plug into GitHub or DevOps tools or Slack bots or plenty of Salesforce applications, apps for everything. But there are a lot of them and they're also complicated. And we saw that the average enterprise has 42 third-party apps connected to their SaaS environment. And fun fact, 22 on average are no longer used, but still have access to sensitive data. So, and when we say no longer used, not used for 6 months or more. So this is something we've seen in practice. This is something you can probably come across in your own organization if you take a look at what apps have been authorized for your SaaS applications and who's still using them. Did they become outdated? Did they become deprecated? It's an interesting side of things because you also have like a lack of insight from the security team, perhaps. So maybe the security team has great endpoint monitoring and they can say like, yeah, like no programs have been installed on all the laptops, or we have MDM, so only certain things are on the phones. But in a lot of cases, we found that security teams didn't even know that some or all of these apps were installed and did have access to the data that they had. We also see that 95% of companies with external users have been 95% of companies have external users that have been over provisioned. So modern SaaS environments have functionality for external users, like customers, partners, contractors, managed service providers. So maybe it's called a guest user, an external whatever. We found that a lot of them are significantly over provisioned. Oftentimes you only need to discuss one thing with an external user, one topic, one document, etc. But a lot of times we've seen that these users have much more access than they need to, access to sensitive company information that they don't need for the function of their job. And so we've also seen that in 55% of cases, a login wasn't needed at all to access certain data. So companies had sensitive data publicly exposed to the anonymous internet. So this isn't even guest and external users. This is just sitting there. And we'll talk a little bit more about this shortly. We also saw that one of the challenges with SaaS is that it's very heterogeneous. So enterprises use dozens, if not hundreds of SaaS apps, and each of those apps has multiple releases per year. So this means that even if your organization is standing still, your SaaS environment is changing underneath you. So you may add more users, you may add new permissions, purchase new functionality, etc. The vendor's making updates. So you get hundreds of updates across all of the SaaS apps just within your organization when you think of all of them together in the span of a year. And so here's some concrete examples of how companies are now being attacked. So Teespring had previously evaluated third-party service WayDev, which required access to some of its data. This was implemented via OAuth, and WayDev retained that OAuth token, and a third party later accessed the token to gain access to Teespring. Rakuten exposed a bunch of data because it failed to notice a change in a Salesforce security setting that was just part of a regular update. And so data was accessible to the public internet for nearly 5 years until it was discovered. SolarWinds, more recent, has received a lot of attention. It was a supply chain attack where people infiltrated SolarWinds and were using a lot of different techniques to bypass identity and access management and laterally move, so like pivot from victims' on-premise networks to their cloud-based Microsoft 365 accounts. That's there's a lot of complexity in an advanced attack techniques that were used in the SolarWinds breach. It's pretty interesting. Some of the original attacks were, or some of the first issues were not so interesting, but the pivots and the persistence established were quite interesting. So let's talk about some real world scenarios here. So attacks or incidents involving or resulting from SaaS and SaaS usage. So public Google Sheet. This is an easy mistake, or a public Google Doc, or some Google thing that has been shared. So this is possibly you've seen this. It happens a lot. This is a particular incident we're looking at. A company hired a third party to build websites for them, and then the third party put Drupal, Akamai, and New Relic creds into a Google Sheet. The Google Sheet was public. So finding those creds would have allowed RCE and access to everything for all of those domains. A security researcher was able to find this doc. I believe they used a URL shortener, but they were able to find this public URL that had just a list of credentials that allowed for remote code execution on the original company's websites, like multiple websites, just because the sheet was misconfigured. So presumably the third party needed to share these things. They didn't have the same email domain as the original company. So instead of sharing like with particular emails, they just shared it publicly. Sometimes when this has changed recently, but sometimes the flow and it also depends on the provider, various providers of document editing and document sharing have different approaches to this and different approaches to sharing. So sometimes you'll see a workflow where it's just like very easy to share a doc, but then maybe that's the default behavior to leave it publicly available. So it's a pretty easy mistake to make. What went wrong here was putting keys in a spreadsheet, also not the best practice, and making it public. This was a quick and easy example, but it's common. It's easy. It's part of the nature of collaboration now. Another example of a SaaS incident. So we had a customer support portal. We as in the world. It wasn't an App Omni support portal. This support portal overexposed data. So here we've got our portal. So it's a help forum, customers, suppliers, etc. can talk here. Customer support exists here. 95% of external users here were over provisioned. So the following screenshots show external user access and permission. So we've got a pretty straightforward little website. And here's what's underlying. We've got the case table, which has the permissions that agents can read, write, create, and delete. Support portal users can read, write, and create. So here we can see like here are a bunch of IDs of the things in this table, and here's the portal user, and here's the title and the description, etc. So this information was actually overexposed because support portal users couldn't just see their own data. They could see everyone's data. They could read, write, and create arbitrarily. So what was showing up was only the incidents that affected you. So, but what happened in practice is you could hit this API with different case IDs and they would be returned to you. So you could see the cases for other users, even if they're not your own. This was a result of kind of assuming that the front end was protecting the back end. So by only querying originally for the appropriate cases, what gets displayed to the users, fine, it's what they expect to see. But what actually happened in the back end is that that user could query any case and see any case information. So we could also try the same technique using users instead of cases and query different user IDs. So what the outside world should have seen was what was here displayed in the UI. What the outside world did see was that any support portal user could see any data belonging to any other support portal user. So they could see attachments, emails, users, email templates, like a whole bunch of objects available beyond just their cases. And like they could see the actual data about these users because it wasn't restricted on the back end. So what went wrong here? Portal administrators confused UI visibility with access control. There was no security change management process for SaaS. So like as things were being built and developed, there wasn't an SDL around it. There wasn't a security development lifecycle. It was just configure and update as fit, as desired. The security team also lacked the domain expertise in the access control and data sharing models of the SaaS application. So it's a bit tricky. You're a ProdSec team member, you're a security expert, and you've learned all these hacking techniques, and you can do buffer overflows and cross-site scripting, blah, blah, blah. Do you know Salesforce? Do you know ServiceNow? Do you know Workday? These are super complex applications that have the complexity and the power even of certain operating systems, are entirely different, bigger programs and require a lot of domain expertise. And it's common to just not have that. It's common to know web app security really well and not know these SaaS applications. It's tough. It's a lot of specific domain knowledge that's required. So that's what went wrong here. Another issue that we'll talk about is open S3 buckets. So this is analogous to SaaS misconfiguration, and I think a pretty good example of how things can go wrong. So open S3 buckets are a super common issue. Like it happens maybe less frequently now, but still pretty frequently, and we've seen them over the years. AWS S3 is a data storage. It's a place to dump data, view data. Really powerful tool, really commonly used, but it can be misconfigured. So it is infrastructure as a service, but there are countless parallels between infrastructure as a service and software as a service security concerns. SaaS is trailing a few years behind, but it's catching up. The biggest parallel and the biggest thing to note here is the shared responsibility model. So you have, in this case, like data exposed unintentionally, no hacking was required. During the transition to cloud, it can be easy to forget this shared responsibility model. It happens with infrastructure as a service. It happens with SaaS. Shared responsibility model means there is a responsibility of both the provider and the consumer to follow security best practices. So Salesforce, for example, has a security team. They are working very hard to provide peace of mind and security around the Salesforce application. But there's also a responsibility of users of Salesforce to know how to secure it, how to, from their end. So you don't have to build in the cross-site scripting protection that's built into Salesforce, but you do have to look out for what data you're exposing where, what permissions you're granting to which users. It's a lot more complex than that, but it means you, out of the box, these things aren't going to get hacked necessarily, like they're not leaving a whole bunch of data publicly exposed, but through misconfiguration, you, the user, could. You could over permission folks, you can have configuration drift, not make use of the best practices that they recommend. So there is a responsibility of users of SaaS applications to make sure that they're being used securely. It happened in infrastructure as a service. So S3 buckets, you're dumping data in there and you think like, oh, okay, cool. Putting some data there, that's fine. People crawling the web will find open buckets, and then maybe you've put extremely sensitive company confidential information in there. And the same can happen with SaaS. It's a pretty one-to-one example of how things can go wrong. And it's much more common to think about open S3 buckets, or like if you're a security researcher poking at a bug bounty, poking at some product, you look for open S3 buckets. That's the direction that SaaS is heading. People are going to start being mindful of where can misconfigurations happen in these SaaS products and where are the low-hanging fruit. So there's a whole bunch of examples of these leaks. This GitHub page is just some examples. So someone broke into our unsecured AWS S3 silo, added non-malicious code to our JavaScript SDK. That's one example. Exposed AWS buckets, again, implicated in multiple data leaks, passport scans, tax documents, background checks, etc. 7.2 million records were exposed, but not from the app. They were exposed from an S3 bucket. Misconfigured database, breaches thousands of patient files, names, email, and postal addresses, etc. These are the headlines of these articles. They're all S3 buckets. How a vendor for half the Fortune 100 exposed a terabyte of backups. Medical records and patient doctor recordings exposed. Jewelry site accidentally leaks personal details, and plain text passwords of 1.3 million user addresses, etc. That just took us to 2018. So didn't go farther back than 2018 in these two slides. That GitHub page has more examples. The internet, just Googling stuff, has more examples. There are a ton of them. So something worth noting about open S3 buckets and other bugs is like as they become more known and they become more common, more tools start to exist. So now there's a lot more automation. Now there are a lot more tools that exist for both exploiting and securing S3 buckets. And these are pretty easy for infrastructure as a service specific tools, but they're hard for people. So one person can't just crawl the internet and look for stuff. One person has more trouble thinking like, oh, have I made sure that every S3 bucket follows this? Or like, have we set our policies up? An automated tool doesn't care. It just searches everything. It just trawls the web and looks for open S3 buckets. It's easy for tools to find this. It's easy for tools to prevent it. You can run a tool that says like, hey, yeah, all your S3 buckets are private. You're good. It's harder for people to manually audit that and to manually make sure that it is secure in the first place. And these are more common now. They're more common knowledge. They're more expected. So people are still on the more on the lookout for them now. But they can still happen. So it's a little bit less of the Wild West now for S3 buckets, for some infrastructure as a service stuff, but bugs still happen. Mistakes still happen. What went wrong here? Forgetting the shared responsibility model. When you are working with S3, when you're working with other providers, you need to be mindful that their security will go so far and then you have to pick up. It's important to include these considerations into design and deployment. The security team doesn't always have domain expertise. Maybe like the security folks are great at security, but haven't seen AWS as much or S3. Also, not making use of automation. So this was a little bit harder in the beginning, but now there are so many tools for S3. And we're seeing this shift in SaaS as SaaS catches up, as vulnerabilities and exposures and leaks become more common. Things get brought into bug bounties. Researchers start looking more. They're looking all the time, but now there's more common knowledge, and we're only just starting to see tools and automation around that in the same scale as for infrastructure as a service. So now let's take some time and talk through some hypothetical breaches, work through some mental exercises to see how your organization might handle these things. Third-party app breach. So here's the scenario. You're the sole security person at your organization. Schedule.ly, some scheduling app, not a real app, is a small but popular productivity app. It has integrations with all the cool SaaS applications, Salesforce, etc. You see a news article that says it's been breached. So what do? So maybe you think about data inventory. Does anyone in your organization actually use it? How can you be sure? How do you know? Do you have an inventory of every third-party app? Do you have an inventory of every third-party app connected to a third-party app? So maybe you have a vendor review process that reviews every app that you purchase, but like, oh, Schedule.ly is free. So have you actually reviewed it? What if someone connected it to Salesforce or to Slack or to your other SaaS products that you know you use, but you don't know if it's plugged in there? So let's say, yeah, you have a vendor review process for all purchases and software installs, but this is free and anyone can install it. So now you have to know, are your employees able to install apps into Salesforce, into Slack, into Office 365, into G Suite? And so you find out you're agile and anyone can install anything anywhere. So now your question is, how do you find where it might be installed? So you can ask yourself, do your SaaS apps have pages listing installed apps? Do you need admin access to view? Who are your admins? Can you, as the sole security person, do this? Or do you need admin access to Salesforce? Do you need admin access to Slack? And what if you're not an admin of any of those? So now you have to go hunt down your admins. So let's say you know all your admins and you have them investigate. So they go trawling the SaaS apps and find it's installed in Office 365, Salesforce, Slack, and G Suite. So cool. Now what? Also, we're ignoring shadow IT for now. So let's pretend that we actually do have full knowledge of all the SaaS applications and that like someone didn't sign up for cool new service for free and then install it there. So great. Now we want to contain the breach. We know that this is not a trustworthy, not that it's not trustworthy. It's been breached. We need to revoke access. So then how do you disconnect it from all of them to contain the breach? Now you need to look at the app uninstall flow for each of these SaaS apps. Fortunately, it's fairly straightforward in this case and your access is revoked, but it's important to be mindful and prepared for that. Like, what if it's not? Do you need your admins on call to be able to revoke that access? Is there any automation you can do around that? What is the process there? It's important to know how that works instead of trying to rush to find it out. So great. We've revoked access. It's no longer installed in a 365 Salesforce, Slack, G Suite. So now the investigation begins. What data could it access in each of those? You as the security person, the one security person, need to figure out, did something bad actually happen? Did you dodge a bullet and nothing was exploited? Or was data taken out of these? So now we have to ask, what data could it access? So then you need to know what permissions was it granted in each of the SaaS applications? And then what do those permissions mean? So all of these platforms have a lot of scopes and permissions, like hundreds of scopes and permissions, sometimes per platform. Some of them grant broad access, some of them grant specific access. And some of them install at a system level, some install per user. Each platform has its own access management. So this is actually a complicated question. So here's a subset of Slack scopes. This is just the first handful of admin scopes. There are a bunch more. Here's some of the Google APIs available through apps installed to Google. So handful of the first scopes available for Google Calendar. These are Salesforce scopes. So just a little handful of the ones that are available there. Here are Microsoft scopes for calendars, but this is just the first few of them. So these are 4 different apps, different naming conventions, different permissions, different scopes, different types of installations. So it's complicated, but let's say you go through, you work with the admins, you do the work, you read up on everything. Now you know where it was installed and what scopes it has in each SaaS app. So you know what could have happened. Now you need to see what did actually happen. So you've got your like worst case bound on what this incident is because you know all of these scopes. But did it actually do stuff? It could access calendar information. It could access Salesforce objects, various Slack channels. Let's say that's what we found out was available to it. But did the attackers do that? So next step, you reach out to the vendors to ask for help. So you can reach out to Salesforce, Slack, G Suite, etc., and you ask for their help. You can reach out to Schedule.ly, but let's say they're a tiny team, tiny company, they don't have a security. Maybe let's say they're 2 people working on a side project and they don't have a security team. So you can reach out to the larger vendors and see like what logs they have, maybe how they can help you, and maybe they can help. But it's an incident. Time is of the essence. So you start pulling logs from each of these SaaS applications. And so you need to make sure you have access to them. Like, how do you actually view these logs? Do you have access? Do you need your admins again? Were these properly configured with your SOC from the get-go? Do they have special formats? Like, were you processing them all along? Were you not? Also complicated. And then once you've answered, do you actually have these logs? You need to see what is in them. How do you make sense of that data? Do you have information about what connections were made, what API endpoints were hit, what scopes were used by Schedule.ly? So let's assume that we've been able to find out what data was accessed and where. Now you need to figure out, does that actually matter? So if it was Salesforce, like, does it contain customer data? If it was a calendar meeting, did that calendar event have people outside of your organization on it? Did it have customers or prospects? Does their name and email count as customer data or PII? Where is your company located? Like, does GDPR fall into this? Was it data or metadata? Was it company financial data? Was it employee data? What legal or compliance obligations are there? So now you're digging into like the actual data stored in each of these SaaS applications to try and see what it affects. Does it matter? So you need to figure out, like, do you tell people what's required, what's ethical, what's best for the company? Then let's say, figured that out. How do we prevent this from happening again or mitigate damage if it does happen again? Complicated question here. Like, do you want to require that every app, even auxiliary apps, go through vendor review? Should Schedule.ly have gone through vendor review? Should SaaS applications allow users to install apps to them and to approve apps, or should that be locked down? Should every additional app require a security review? Do you want to bring your SaaS applications into the SDL? How do you do an app permission review? Maybe now you want to go look at all the other apps and see what they can access and should they. You also want to make the next incident easier. It's like no one's perfect. No app is perfect. Breaches happen. But you can lower some of the pain. You can make it easier in the future, and you can make incidents less bad. Maybe you want to introduce audits that are timely. It's there are a lot of open questions here, and it can depend on your organization. So now we come to some supplemental data. So we've talked about those thought exercises. There are a lot more. It's good to think about these tabletop exercises. It's good to be prepared and like think about how you can make incidents less bad or prevent them even. But SaaS introduces another layer of complexity. And so App Omni conducts risk assessments, and we have some aggregate data here about risk assessments that we've done for, these are specific to Salesforce, but they paint a pretty broad picture of the state of SaaS security. So in more than 35% of our risk assessments, we found that security posture best practices were not followed, that things were misconfigured. In over 30% of our assessments, we found compliance violations. So NIST, for example. In over 99% of our risk assessments, we found data access misconfigurations. In over 55% of them, public data records that were just exposed. So we talked previously about information publicly exposed online with no access required. We see that in over 95% of the risk assessments, we've seen over permissive integration accounts. And the average number of insecure secrets or credentials stored in Salesforce is more than 20 per risk assessment. So we see a lot of data overexposure and account over permissioning. These are very common. The previous hypotheticals are not that outlandish. The branches that we had to walk down as we thought about who could access what data and what was really going on, that's a worthy concern. And if you encounter an incident that comes across a SaaS application, it's something you'll run into. We see this, and we do see it in other clouds as well. And you can see in other products and other applications as well. And you can see news articles on this sometimes. You'll see bug bounty reports, blogs, etc. There's a lot of content, and it's growing. It's getting more attention. Does this mean we shouldn't use SaaS? No. All of this sounds daunting. Breaches happen. They will continue to happen. The hypotheticals there test us and test our teams. And in reality, like, we will be tested. Our teams will be tested. Security will be tested. But we can prepare for these, and we can ask ourselves questions in advance. So what you don't want is to come into an incident and start having to ask those questions, like, who has this data? What apps have this data? There were a lot of hypothetical questions there. It's much better to know that ahead of time and not be caught off guard. So here are some summarizing questions to start the discussion of, like, how can you evaluate your posture, your SaaS security posture? So we want to start with inventory. So what systems exist? What data do they hold? Who's in charge of them? Who can access them? These are pretty fundamental. Knowing what's going on in your organization is going to help in the event of a breach, and it'll probably help prevent a breach, because if you start to see more systems than you need, or data being scattered across various systems, people who have more access than they should, then you can correct that and you can change it before it's an issue. Then we want to look at app inventory. What third-party apps exist? What are the settings for each SaaS application for installing third-party apps? Should they be more restrictive? Should apps be subject to review? Your mileage may vary here. Your organization may have the capability to do this. It may not. You have to make the choices that are best for your business. I've seen a lot of companies that do review everything, including the apps that are installed into their SaaS applications. And it is not quite as fast as allowing everyone to install anything, but it gets everything reviewed and it makes sure that there's still an inventory there. But knowing what exists and knowing how to access that information, that's important. So system configuration. These apps are very complicated. They have a lot of settings. You want to know what they are. What are the configurable settings? And what are the best practices there? What does the application provider recommend? What do other security companies recommend? Are there benchmarks? Are there compliance standards that say, hey, these are the settings that you need to consider this a secure implementation of Salesforce, for example? And we see like a bit of a security double standard here. For web application security, we've got code analysis tools, vulnerability scanners, security guidelines, best practices, web application firewalls, runtime protection. And for SaaS application security, hope for the best. So we can do better than that. And you really want to think of like, we have all this security expertise. We have people who are security experts. How can we bring that mindset and all of that expertise into our SaaS deployments as well? What should an org do to better secure their SaaS? And so that brings us to recommendations, the steps that you can take to collaborate securely. So the grand question, what should security teams be doing to better secure their SaaS? Prepare your organization for success. Embrace the SaaS shared responsibility model. Know that you are using complicated applications and you do have to do some work to make sure that they're used to their full potential and full security. We need to clearly define ownership for SaaS security. Who's in charge of it? If you don't define this, people will do their best, but people are busy. So admins are going to work hard to make sure Salesforce is running smoothly, and they'll try and secure it, but it's a busy job. And the security team can have expertise that can be helpful there. So it's important to know who owns what, who's responsible for what. We also want to recognize the limited scope of commonly used tools like CASBs and pen tests. This is not to say that they are not helpful, but it's important to know the limits of everything that you're using. If you're looking at a point in time evaluation of a SaaS implementation, that's great. Like you could be perfect then, but in a few months, it could change. More apps could be installed. And if you're not constantly evaluating that, it gets trickier. And if you're not sure what third-party apps are connected to the SaaS application and that's not limited, that can be trickier. There's a lot of complexity here. And there are tools, there are approaches that can cover certain areas and that can give you more defense in depth. But it's really important to not rely on something that maybe isn't giving you the security that you need. So you want to take a proactive approach to, don't wait for a breach to take action. By thinking about these things ahead of time, thinking about what you're doing, who's owning what are the limitations, thinking about all of that is going to be really helpful. So you want to protect that data. You want to secure your data, not just the perimeter. You want to gain visibility to who has access to your data. Implement guardrails for your users. Sometimes people make mistakes. A breach doesn't necessarily mean malice. It can just be a mistake. These are complex things and we're all human. Continuously monitor your SaaS environment. So point in time can give you an idea of the security of something in general, but these are rapidly changing. You don't run like an antivirus software once a year, for example. You have tools, automation running continuously. The cool thing about all these apps is that they're so powerful. They have all these APIs, they have information and automation potential that you can be continuously monitoring them and making them secure. So take inventory ahead of time, take it regularly, stay up to date on where it resides and who has access, evaluate if users are over permissioned, and automate it. Monitoring and detection, understand the logging of your own tools, but also of the SaaS applications. Monitor these logs as you would others. Treat SaaS applications with the same intention as any other application. They're powerful, they're important. Know where the logs are, how can you combine them, how can you look at them, who's making use of them. It's nice if you can close a potential issue as it didn't happen. or know with certainty that your org is safe. Have a vendor risk review process in place, subject everything to it, large SaaS apps, small third-party apps. This is a best practice. It depends on your resources, but these are just recommendations for best practices. SDL, the security development lifecycle, it applies to software development, but it can generalize to SaaS deployment. Powerful SaaS apps can run code or have custom apps and integrations. If you're on a project team at a company building software, then you're working with people to ship secure software. You can also work with the people shipping Salesforce updates or shipping SaaS changes to make sure those are secure. Misconfiguration is common, but following a process for secure development and deployment can help. And so that's the end. That's all the recommendations that we had. And now that'll bring us to the Q&A. So thank you, everyone. And talk to you live in a second.